Hello everyone and welcome to this new episode of the Avalonia UI series. As you may have noticed from the title, today's topic is grids. The grid is one of the most flexible and versatile layout controls, which can be used for arranging child controls in columns and rows. Each child control can be positioned in a grid cell using column and row coordinates, which are zero-based, and both have 0 as default. The size of rows and columns can be defined as absolute, relative, or proportional. There are at least 3 types of grids available in Avalonia. The first one is standard grid. The second one is the uniform grid, which is a standard grid that divides evenly the available space for rows and columns. Third, we have data grids, which are available through an additional Avalonia UI package and can display repeating data in a customizable grid using something called data templates. But today we'll focus on standard grid controls. Let's see some code. Alright, here is the solution and the project as we left it in the last video. All I did was I created a new page for the grids and the related view model. Then I just updated the view engine that we saw in some previous videos so that the new page can show up in the sidebar menu, as you can see here. All right, great. This is a preview, and that's all it's doing, the new page. As you can see, there isn't much going on. There's the usual scroll viewer, so that we can scroll up and down the view. And then there's a stack panel where I stacked a couple of text blocks. One is the title, a subtitle for the grids, and this is a templated control that you already see in previous videos. It's just a template that allows every view to have more or less the same look and feel. So let's move on with grids, and let's start with the tag. The XAML tag for grids, you guess it, is grid. Cool. Now this is the tag, and we can start by, you can just put content right into it. So let's start with some rectangles maybe, like this. And fill the rectangles with some colors that I already prepared somewhere. Here we go. All right, this is one color. I picked a color palette somewhere from the internet. And let's duplicate the rectangle with another color. All right, at this point you can see that there isn't much going on. Usually I've learned the hard way that with Avalonia, if you don't see something, it's probably because you need to define some height or width. So let's go with some width. Like, let's say that this rectangle has 100, nothing yet. So let's set the height, and here we go. So on the right, you can see the Avalonia Rider plugin, which is showing up a preview. Okay, what happened? We set width and height on the first rectangle, and the second one is showing up. That's because the order, when you don't define anything, the order is important. So the first one is the first rectangle has established width and height for the whole content. To have a clear view of what's going on, let's use this cool property which is called show grid lines, and let's say true. Okay, this should pop up some dotted lines somewhere. We don't see it yet, but we'll see it later. And given that we are here, let's copy paste the sides for the second rectangle. All right, now that we set width and height on the second rectangle as well, we can see that the rectangle is more or less real. It has a real size, like 100 times 100. Now let's add some more rectangles. All right, as you can see, the last one in the list is always the one appearing on the screen. That's because Avalonia is drawing actually not Avalonia, the grid is drawing the rectangles in the same order that they appear inside the tag. So if we comment the last one, you can see that, all right, this is the first one, and then the other ones. So now, how do we position? How do we set the position of those rectangles? The grid in Avalonia has indexes. Every element in the grid needs to have an index, one index for the column and one index for the row. Rows and columns start from 0 and they start from top left. So we can define those like this. Go on the contents, go on the control you want to set, and just write grid dot row, and then assign an integer. Same thing with the column, like grid dot column 0. Okay, so this element is on row 0, column 0. Let's do the same for the second one, and this time it will be on the same row but on the right. So it's going to be column 1. Nothing is moving and someone is complaining. If you can see, it says column index 1 is out of grid column definitions, range 0, 0. It means that this grid now only has one column and one row. So basically a square, one cell. So we need to tell the grid that we want. What do we want to do? We want to do 2 columns and 2 rows. All right, we need to tell the grid that we want 2 columns and 2 rows. And we can do this by setting the row definitions and column definitions. Definitions properties, right? So basically we need to define the sides of each row and each column. The sides can be absolute, where we specify the sides as an integer. It can be, and that's just like putting a number like this. Then we have the auto definition, which means that the sides will fit the child control, right? So it will take up the space that is needed by the control. And then we have the star. The star means that the control will expand as much as possible, taking up all the remaining space. So let's start with stars, like this, and stars for the columns as well. Cool. We can see something is going on in the preview. You can also see the grid lines and the first 2 rectangles, which are square at this point, but never mind. All right, now that we started to see something, let's move on with the indexes, because we need to set the indexes for all the elements. Like this and like this. So the third one is going to be, let's say, the second row, the fourth one, the second row, and the first column and the second column. Well, sorry. And the second column. So colors should match. Yes. Okay, first, top left, second, third, and fourth. Cool. But now to see the full potential of the star definition, we better set. All right, let's get rid of width and absolute width and height, which doesn't make really sense if we want to use the star definition. Cool, let's get rid of it, and let's set the grid size. So let's give it a height of, I don't know, 300. Let's make it 400, a multiple of 2, and then a width. I think width is okay because it's expanding. If we set it to 300, we can say 400 as well. Maybe 500. So they are, let's go with 600. So they look like rectangles. Cool. Now you can see that rectangles are showing up even without any width or sides defined on the child elements. At this point, we can use the start definition with proportions. For instance, if we want the first row to be twice the size of the second one, we can just say that the first row is 2 star and the second row is just star. So you can see the proportions here changed. And we can do the same for the columns, like this. We can say that the first one is 1 and the second one is twice the sides, and you can see that they change accordingly. And at this point, the sky is the limit, because you can basically do whatever you want with grids. You can have nested, well, let's get rid of one rectangle. You can have nested elements. For instance, you can use a stack panel, and always remember to define proper indexes. So this one was the second row, second column, and let's put, I don't know, 2 buttons in it. Let's say test, and the first one is test 2, and you can see they show up properly. At this point, the more you play with it, the more familiar it will become. But in the end, I promise you, you'll be able to do basically anything with the grid component. But now let's see how we can populate the grid using code behind instead of XAML. First thing we need to do is to delete anything from the XAML and leave just the grid tag. You can see from the preview that the grid is empty now. Given that we are playing around with code behind, we need to declare a variable name for this grid so that it will be visible in the code behind. And as a name, we can pick basically anything. I'll call it main grid. And now let's head to the code behind. To access it, you just have to go in the project explorer and locate the XAML file, just expand it. This should be similar whether you are using Rider or Visual Studio, and just click on the CS file, which is behind the XAML. That's why it's called code behind. Cool. We'll use the last minutes of this video to go through a simple exercise where we fill the grid with a bunch of white squares, and we'll create a very basic animation simulating a colored square going through the grid from the left to the right and from the top to the bottom. It's what you've seen at the beginning of this video, basically. Okay, to start off, we need an init method just to encapsulate the code we are going to write. It can be private, doesn't have to return anything, and we can call it init grid. Before we start, we need some variables, some supporting variables. For simplicity, I'm just going to copy paste because I already prepared this exercise. And let's define a basic color. This will be the color of the basic color of the empty square, let's say. Eyebrush and brushes are eyebrush and brushes are types that come from the Avalonia package. Cool. So let's say we have 10 rows and 10 columns. The first thing that we need to do is to loop through all those cells. Let's say, imagine it as a matrix 10 by 10. So we need 2 for loops. It's a very, very common practice. So those are 2 nested loops. Then high level, we need to, for each cell of the grid, we need to create a new rectangle, give it a size, a filling color, and then add the child to the grid. But before moving on, I think it will be very useful to have the preview. Having a preview showing up will drastically speed up the development process. So we can split the view in 2, like this. All right. Cool. So on the left, we will have the code behind, and on the right, we can have the XAML preview. To do this, if you have the preview plugin installed, just click on the preview only. All right. And the more code we write, the more things we should see popping up on the preview. The difference from working with the XAML directly is that when you work with code behind, in order to see the preview, the updated preview, you need to build the solution. And on Rider, you can quickly do it with Control B, like this. Cool, let's move on. Cool, so we said that for each row and each column, we need to create a child, which is a rectangle, we said, rectangle. Make sure you pick it from the Avalonia package. This rectangle will have, let's say, a width of 40 and a height of 40. Let's give it a margin of 1. The margin is defined as thickness, and you just give it the integer of your margin and fill it with the base color that we declared at the beginning, base color, like this. Now that we created the child, we just need to add it to the main grid. Do you remember that we defined the variable name in the XAML? And access the children. The grid has a children collection of controls declared. And you can simply add the child, like this. Cool. At this point, there are two, if we just build, we shouldn't see much going on. Of course, because we need to call the init grid method. The code behind class has a constructor which has this initialize component, which is from Avalonia. After that, you can call the initialization, our custom initialization method, and let's see if we get something popping up. Not really. But actually, we can see a white square, and probably those are all the 10 by 10, so 100 squares, one above the other, right? That's because we didn't define, as we did for the XAML, we didn't define row definitions and column definitions. And to spare you some time, let me just copy paste it. And we need to put it here, so between the first loop and the second one. That's because, as we did for the XAML file, we need to define each row and each column only once. So we've got 10 columns and 10 rows. That's why I'm using only the first loop, because I want this to be executed only 10 times, given that this is a square matrix. And this is doing the same exact thing that we did with the XAML. We are accessing the main grid, the row definitions, and we are adding a row definitions, which is a star. Now that we got definitions, let's build and see if anything happened. Something happened, definitely. You can guess what it's missing. Given that we need to replicate everything we did for the XAML, we are missing indexes. We need to set indexes. So let me copy paste the rest of the code. And it took me a while to understand how to do it, but this is simply how you do it. It's grid.setRow. You give it a child and the index of the row or the column. This is going to set a property on the child that we just created according to the index, with J is for the row and I is for the column. And that's it. So if we build again, at this point, we should see something working. Yes, it is. Now, I think we need to tweak the size of the grid just to make it look better. Let's see. I think we can do it via code behind by accessing the height, and we can set it to let's see, 500 maybe, and maybe the width and set it to, it's a square matrix, so they should be equal. Let's build. And voila. Every time you build, you will need to wait like a fraction of a second for the preview to get updated. And if we scroll down, we can see the grid. Cool. Another thing that we can do is to help us visualize better the grid is to show, this main grid, show grid lines, and set it to true. Cool. Build it, and voila. All right. Now we need two buttons, a start button and a stop button. For simplicity, let's go and tweak a bit the XAML file, and in order to have the buttons on the left and the grid on the right. I'll speed this up, so I'll spare you the details. If you're interested in how this is working, you can always find the source code on GitHub. Let's see you in a second. Here we are. So I created a new grid with just two columns. The first one is defined as auto, so we'll take the space needed by the inner elements, and the second one will take up all the space. So on the left we will have the buttons, on the right we will have our inner main grid. And that's why at the beginning I said that the grid is very versatile. You can create and nest as many grids as you want. Nice. The first button will start the animation, and we will see the little colored square going from left to right and top to bottom, and the second button will just stop this animation. Given that we are working with code behind and we are not using the MVVM, when we deal with buttons we can just set the click property and we can create a method. Of course, I already created all the methods and I'll just copy paste them. The first one is called let's call it start on click, and the stop one, you can guess it, it's called stop on click. Cool. You can use your IDE to create the methods automatically by just click on create event handler, but I will just copy paste it. Let's go back to the previous layout so that we can see the code behind and the preview. We don't see the preview because there is a compilation error, but we will fix it in a second. We just need to copy paste the start and the stop on click methods. All right, here we go. Let's compile and see if it's working, if the preview is working. Yes, the preview is working. So here we have the start on click, which is assigned to the start button. The start method will loop through the main grid children. For each child, let's ignore it for a second. For each child, we will derive a rectangle. If it's not a rectangle, we move on, but this shouldn't happen. We'll get to this later. We take the rectangle and fill it with this green color. And then we wait for 100 milliseconds just to make the animation a little bit more visible so that it's not instant. And we repeat the loop over and over for all the children's. Now, what we want to do is make this green square move through the grid. So it means that when we are at child 0, we make it green. When we move on, we make the second child green, but we need to make the previous one. We need to set the color of the previous one to the base, back to the base color. And that's why we have a previous rectangle. We store this previous rectangle, and every time we move on, the current rectangle becomes the previous one. And so on and so forth for all the children's. So let's still ignore the stop. I'll show you what this last line does. Now let's compile. And with the preview, you can even test the buttons. So let's click on start, and you can see our dear colored square moving on. All right. Let's wait for the end. Cool. the animation is finished, and you can see that the last one is still green, and that's where the last line of the code of this code comes into action. If the previous that we set is not null, fill it with the base color, just when the for loop has ended. Nice. Now we need something to stop. Let's rebuild. Now we need something to stop this animation, like this, because otherwise it goes over and over until the end. And here we got the stop method. So what we need to do is to have a variable that can stop the for loop inside the start method. And this is what line 54 does. So if this variable is set to true, then we break the loop. And we set this variable to true in the stop method. So when we click the stop method, we set the variable to true, and the rest of the code here will make sure that we reset all the squares back to the base color, so we don't have any green square going around. Let's test it. Start, and then stop. We can do this multiple times. And that's it, our beautiful yet simple grid animation. And that was all for today's video. There are many other things to explore around grids. It's a very powerful control that opens up to a variety of possibilities. I hope you enjoyed this video, and if you have any question, feel free to leave a comment. The source code of this application is available on GitHub. You can find all the information in the description below. That's all. See you in the next video.